We're now going to end up being able to put all the things together. We've got lots of geometry language. We have crazier pictures. It's just an angle puzzle. Do you guys want to try this one without me?
Yes, we can do it.
No? Okay. If you want to try it on your own, you try. If you're not trying it on your own, the first thing you're going to do is read in the diagram below. How do I say this?
A segment AB is
Perpendicular to.
AC.
Okay, so that means I got 90 degrees, right? Okay, let's find that one. AB is perpendicular to AC. So I'm just going to put this right angle marker here. Oh, what kind of triangle do I have? Right triangle. Woo, okay, now we got DE is, what's that symbol? Perpendicular to CB. So be careful. DE is perpendicular to CB. So this intersects with this, right? Here. So I can put right angle markers on both sides. I typically do that. Am I done reading the problem yet? No. Oh, gosh. Okay. Then it says the measure of angle ADF is 52. Okay, I'm finding it. There's the 52. So now ADF, do you see how you can, the angle is framed by those two sides. And angle B is 50 degrees. Okay. Find the measure of angle EDF. Find that angle, put a star there, and then see if you're going to match me. Find EDF. Remember that the letter in the middle is the angle's vertex. Ooh, I can't spell today. Vertex. So EDF. This is the angle I want to find. I'm going to put a star right there. All right. So certainly we have perpendicular lines. We have 90-degree angles. What other shapes do we have?
We got parallelogram.
Do we have a parallelogram or do we have a quadrilateral? Okay, so a quad, and that's okay, but how many, so what do we want to know about a quad? There's how much in a quad?
360 degrees.
And then what other shape do we have?
A triangle.
And what's the triangle sum?
180.
180. So there's more than one way to move around the triangle. Okay, you might start with this big triangle, right? You could start with the big triangle. You could start with this triangle. See what I'm saying?
Yeah.
Start to find some angles. On your mark, get set, go. I wrote down these facts because these are going to help me out. What I know about triangles is that it's angle plus angle plus angle equals 180 degrees. So typically what we do is we take the two angles that we know, we add them together. That's going to give me the 142, and then I have one more angle that I don't know, equals 180, right? Do you agree with that?
Yeah.
Okay, so then I'm going to subtract my 142. I just didn't line those up. Okay, so now this gets me the 38 that's here. Okay, I don't necessarily write it out this way, but that's what this is what you're actually doing. It's the triangle sum theorem. Okay, so now if I'm just working my way into this quadrilateral, quadrilateral right here, then I'm going to go with the 58 that I just had, or 38, my bad, the 38 I just had, and I'm going to look at this point, and I'm going to think about an upside down rainbow. Because an upside down rainbow, aka a protractor, is 180 degrees, right? So those two angles are supplementary. So if I take 180 and subtract the 38, that arithmetic answer is 142, which, oh my gosh, there it is, right? I'm at 142 here, okay? And then if I say that I'm going to go with the quad, and I remember that quads have 360, that means I now have 1, 2, 3 of the 4 angles. I'm going to add those together, 142 plus 90 plus 50, and it doesn't matter the order that I add them in. because addition is commutative. So I put down my 2 and I go, this is going to be 14, that's going to be 18, carry the 1, that's a 282, right? But now I got to do 360 minus the 282, and that's how I'm getting the 78 that people have mentioned, okay? So this is our final answer. So how many moves can we do it in? 1, 2, 3 moves. Some people might do it in 4 moves. Some people might do it in 5 moves, right? We take different leads. Okay. Is everybody ready to go to question number 2?
Yeah.
Okay. So what, like I said, I'm going to go through and teach them and kind of try to bring some conclusions together. All right. So if you read the picture and also look at the picture, we have this. AB is parallel to CD. Okay. And then I also have AD is parallel to BC. So this quadrilateral is a special quadrilateral. What is its name? I said the word twice already. Parallelogram, right? It's a parallelogram. Okay, so let's remember what we need to remember about with parallelograms and their angles. So I like to draw a little sketch of a parallelogram. Doesn't need to be perfect, right? But the thing that's important about parallelograms is opposite angles are congruent, right? So I can put an equal sign there if I want to. And that's true for the other opposite angles. I'm just not going to messy up this picture too much. But when I'm at an angle and I go this way, or at this angle and go that way, these two angles add up to 180, right? So we say they're consecutive angles add up to 180. So like an acute angle and an obtuse angle will add up to 180. Does that make sense to everybody?
Yeah.
Good. That's a math fact we need to know. All right. Now we got to go back to this. The measure of angle ABC is 110. I look around the picture. I don't see that 110 on the picture. Let's find it. I start at A, I go to B, and then I go to C. So what they're telling me is this is 110, but I don't want to put the 110 here and the 110 here. That's when I usually choose to write it on the outside. So I write it on the outside because it's these two pieces add up to 110, okay? Then it says we have angle CDE, which is 37. Okay, cool. And we have ECB, which is 43. Find the measure of DEC. DEC. So I should be putting my star right there. Observation. Do you guys think that an angle is going to be less than 90 or more than 90?
Less than 90.
More than 90. It's big.
Oh.
Do you see how wide it is? Like this?
Oh, yeah.
More than 90. Okay. So let's talk about parallel lines. We got lots of parallel lines, and those diagonals are transversals. And we're inside a parallelogram. So remember the letter Z? What kind of angles are these? Alternate interiors, right? And alternate interior angles are congruent. So is there another angle in here that's 37? Can you make the letter Z?
Next to B.
Okay, so by the B, is it this side of the B or the other side of the B? This side, so 37. So if that's hard for you to see, that's when you want to use your highlighter to do this move. So it's sideways, it's more like the letter N backwards, isn't it? Okay. Is there a 43 anywhere else in the picture? So where's the 43 going to be? So I'm going to go all the way up to the A, but I'm going to cut across the D. So it's up here, right?
Yes, CAD.
Okay. Now, those are great, but I don't know if they actually get me into the triangle I need, do I? Okay, so let's pause. I have this 110 for a reason, don't I? What can I do with the 110? Look, yep.
Subtract 30, whatever
The 37, right?
Yeah.
Yep, so I heard a bunch of people say that. So 110 minus 37 is going to be 73. So these two parts have to add up. Okay, that's good information. Now, okay, but I still am not, then that gives me a 73 up here, but I'm still I'm somewhere. I could do something. Does anybody have an idea? What do you want to do, Amir?
You could put a 37 on that side. Actually,
Can I put a 37 here? Can't put a 30, so this is where people are going to see different things. People might get here and get stuck. It took me a second, but do I see this triangle now?
yeah.
Yes? So if I can find smiley face, can I find star?
Yes.
Okay, this is the thing I need you to see though. What's going to be true about the sum of angle B, all of angle B, and all of angle C? What did we just do up here?
They're all congruent.
So opposites are congruent, consecutives are 180. What's that word? Supplementary. Consecutive are supplementary. So as soon as I know that this is 110, I can certainly put a 110 over here, but then what should I put here? 70. And what can I put over here? 70, right? Now everybody should be one step away of your choice, maybe 1 or 2 steps away. Can you guys get the angle? Some of you might want to subtract and get this angle and then do triangle sum. Some of you might stick with this triangle up on top. I'm just going to keep on doing some arithmetic. So 70 minus 43. So I see that one. Does that make sense?
So if you just solve the one with the smiley face, can't you just get the star?
So if I solve the one with the smiley face, so 73 plus 43 is 116. So this, and then one.
No, that's actually 64.
Okay, so I love that you say this. So these two added together, you're right, is 116, which means this guy is 84. But then guess what this is? Or not 116. This is not 84. What is it? 64. Who said 84? Or did I just not hear you right? 64. What's then this going to be on the other side?
That's going to be 116.
It's 116. So this is the scoop. Do you see? So now I got to use another markup. So this is hard. So here's my tent. Do you see the exterior angle theorem?
Yeah.
Outside equals the 2 remote interior on the inside. Everybody's going to bring a slightly different problem-solving strategy to the table. So a lot of times there is more than one way to get to the answer, but you've got to bring all the strategies. Are you having trouble seeing it, Jerry? Okay. See it? Okay. You guys ready to turn and do another one?
Yeah.
Okay. Okay. So these two came from Delta Math, I believe. These two are Regents questions. So let's look at the slight difference. Typically, they will give you lots of words up top. They may or may not give you any angles till underneath. So you got to read the words on top. Okay, in the diagram below of parallelogram A, B, C, D, I'm going to stop right there, and I'm going to do this. Whoop, 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 whoop. And then I'm going to go 180, 180, right? Opposites are congruent, consecutives are supplementary. Okay, then they tell me I have segment AFGB. The reason why they tell me that is so that I know this is a straight line. That's it. Now here we go. CF bisects angle DCB. This is when I recommend your highlighter. CF bisects DCB. what angle is the angle that's being messed with? What letter's most important in all of that? The C. So at the C, I make a big arc, and this guy is equal to that guy. Does that make sense?
Yeah.
Okay. Now, and I've read that part. Oh, I got to read the next part. DG bisects ADC. DG bisects ADC. So I know right now we're doing a ton of marking on top of itself. You're learning. So this is when you start to, eventually, will you be able to read that and not need to highlight every single part of it? Yes. So once again, though, now this is where things get a little wonky. Is angle D the same as angle C? No. So I would do doubles on these two angles because these two angles are equal to each other, but they're not equal to either of those. And then the last part of that statement just says that the two segments intersect at E. Woo. Of course, you may use the loop. Okay, here we go. We got an angle. Angle B is 75. What is the measure of, go for it slow, E to F to A? Now, I would be looking at that and at least thinking that it should be an obtuse angle and that choices 3 and 4 are probably not the right answer. Okay? Now, let's do part of it first. If this is B, B is 75, then how much is D? 75. How do I get C? 180 minus 75. What's 180 minus 75? 105. So this is 105. And if I need it, A is 105. I can certainly write that inside, but it doesn't really fit for me because I'm a big writer. Okay. Now you have to have some ideas of what you want to do. Clearly, what should we probably do with the 75 because it's up here at a bisected angle? Split it in half, okay? So that does give us a decimal. Guess what decimal it gives us? The 37.5, okay? So I'm just going to do a little arrow into this and put 37.5, and I know there's another 37.5 over here, whatever. I mean, these pictures do get a little bit small. What do you think you're going to do with the 105? Cut it in half, right? So I'm going to divide this by 2 again. Guess what number we're going to get? 52.5. Do you see how they're putting these as distractors? So in here we have 52.5. That's a 5. This is 52.5. And now you just have to start to continue moving around. It is possible, let's see. Ooh, does anybody see a quadrilateral that has enough things going on? So if I want F, can I go all the way up here and then across and then down? Do you see that funny shape I just made? Do I have 3 out of the 4 angles? So it's a little bit, but could you also work with triangles and work your way around? Definitely. So see if you guys can figure out the right answer. Is it going to be the 142 or is it going to be the 127? If you're stuck, I will continue working on the problem. So for me, I see that quad. Oh, I goofed up something. What did I do? Did I goof up? Oh, I don't need 37. How many 37.5s do I need? I'm an idiot. How many 37.5s do I need, my friends? Or what do I want instead? Oh, I made a mistake. I hate it when I make mistakes. Did you see my mistake? So I went, because I cut around like this, I didn't read both 37.5, so the 75. My bad. And there's so many ways to do it. So it's like, Okay. Did anybody else get the 127.5? Okay. You would have gotten it, right? Everybody would have gotten there. We all work at different speeds. Okay. Ready for the next one with some strategy. Okay. And we'll take it slow. Okay. So first of all, looking at the whole, I haven't read anything yet, but looking at the whole shape, does that look like a parallelogram? No. Okay. That doesn't mean there's not a parallelogram there, but certainly E is not going to be the same as C. Okay, we can all see that? Okay, let's go ahead and read through. Quadrilateral, E, B, C, F, and A, D are drawn below such that A, B, C, D is a parallelogram. So this guy right here, A, B, C, D is a parallelogram. So that's actually good news because that means angle A is equal to angle C, right? Okay. Let's keep reading. Oh my gosh. EB is equal to FB. So EB, do you guys see how EB is a really long line? So it's not possible to do the tick mark on there. Does that make sense to everybody? So there's a couple ways you can do it, but sometimes it's easiest actually to just be doing something like this in your head. If EB is congruent to BF, in my head I say, sneak attack! Isosceles triangle, which means this angle here has to be equal to that angle there. Okay. If you want to, could you draw an isosceles triangle off to the side?
Yeah.
Yes. Okay. One more factoid though. Oh my gosh, we got a 90-degree angle on top of everything else. EF is perpendicular to FH. EF is perpendicular to FH. So this is a right angle. Oh. So part of that right angle is part of my isosceles triangle. And the two angles have to add up to 90, aka complementary, right? Okay, here we go. Angle E is 62. Does anybody want to put a 62 somewhere else? Oh yeah, it's C?
Oh, wait, no, A. No, F.
I would be putting it at this F right here. That's the first thing I see. And then C is 51. Ooh, does anybody want to put the 51 somewhere else? Yeah, right here inside our parallelogram. What is the measure of, here we go, F to H to B?
79.
Oh, thanks. Maybe, maybe not. Some of the answers got cut off. Do you guys see that it just says answers 1 and 3? So the right answer might not be there. We'll find out. I didn't know it got cut off. I found that out today. Here we go. Are we ready to find things? Okay, focus on your focus on your isosceles triangle. If the base angles are 62 and 62, what's the name of the angle up at the top? Vocabulary-wise?
Vertex.
Vertex angle. Can we get the vertex angle?
Yes, we can.
Okay, so 62 and 62 is
124.
124, and 180 minus the 124 is going to be
56.
56. So 56 is up here. And if I go over here, this is 56 in here. So I'm inside that isosceles triangle. Okay. What's something else we can do just by doing some easy subtraction?
Oh.
This right angle down here, can I find the other piece?
Yes, you can.
So that right angle at F, right? This is F. This is the line that brings it up to 62, right? And then we have a right angle.
Yep.
So we can find out that this one is not 30, it's going to be 28, right? Okay. So now we have this angle in this very narrow triangle that has my star in it. They told me I have a parallelogram, so I already did the opposite ones, but what's so important about these consecutive ones? They're supplementary, right? So if this is 51, it's going to be, so 50 is 130, right? But it's 51, so it's going to be 129, right? So this is now 129. This is an angle puzzle, man.
We just do
Angle.
subtraction.
So now we have to do some subtraction again.
129 minus 56 equals 73.
73. Do I have friends that agree with that?
Yes.
Okay, 73. We're almost there. And look at how 73 is a choice. Jerk faces. Okay, so here we go. I've got a triangle with 73 at the top and a 28 at the bottom. I add those guys together and I get an 11 and I get a 9 and a 10, right? 101. What is our last angle? Because it's a triangle. Yeah, it is 79. How nice. It did turn out to be 79. I had a different answer on my answer key. I'll see what I did wrong. Oy.